This is Brianna McGowan, and this is my Lab 11 at Home Choose Your Own Adventure Lab, and I chose to analyze a maximally inelastic collision. So my main objective is to analyze a real video and data, and then compare my findings with a model in Python, and I will determine if momentum is actually conserved and how the energy changes. The main result of it was that the data of my observation fit perfectly with the model, and momentum was conserved and there was a loss of kinetic energy during the collision. So I'm going to start with my model, and so I put in all the basic initial conditions. So the mass of each object was 1. One would be moving with the velocity of 1 meter per second, and the other one would be a velocity of 0. Set those conditions and set all the energies with the correct equations. And I also set the momentum equations. And so then when I ran my model, here you see the one moving and the other one at rest. And they stuck together afterwards and move with a different velocity as inelastic collisions do. And so I printed the final velocity of the two combined, which is half the initial, and less the momentum after, and the second is I printed the change in momentum, so there's no change, and then I printed the change in internal energy, which is 0.5. So there was a loss, and I used that equation of the final kinetic energy of the two minus the kinetic energy of the initial. The relevant systems and models in this lab are the momentum principle, where the change in momentum is equal to the net force times the change in time, but during a collision the net force is 0, so the change in momentum is 0, and the momentum is conserved, as we just saw in the model. And with the energy principle, for a maximally inelastic collision, the final kinetic energy does not equal the initial, so the change in the internal energies changes whether it's loss of heat, vibration, whatever, or deformation. And so that is the equation for the change in internal energy, which is what I put in for the model. Then I chose this video to analyze so I can get real data for an inelastic collision. So I tracked the motion of both mass A, mass B, and then when they come together I tracked that as well, of that center of mass. So here I'll play it. I've set the axes and the length and everything. So I took all of the data here. There's the graph of A, the graph of B, and then the combined, and that was their position. And you see this one doesn't start at 0, it starts with when they came together. And then I put that into an Excel spreadsheet, and I then put them into a graph of position versus time together. So you see here, that's the first one together, the other one, that's the center mass individually, but then they come together, that's the center mass of the blue. So yeah, blue is the combined, green is the one that was originally stationary, the red is the one that's moving the whole time. And so I took these numbers and calculated their velocities. So mass A was 1 meter per second in the beginning, and then once it hit at that point it was 0.5 meters per second. And then mass 2, which was originally 0, then became 0.5, and then the combined one was 0.5 the whole time. So if you look at how all of these calculations go, the initial momentum of the total system was 1 in the x hat direction, and the final was also 1, even though the masses were different, the velocities were different. So momentum was conserved, which fits perfectly the data we saw in the model to a T. And then the initial, and then that happened, well, that was the model up there, but you see down here under observation, the same thing happened. And it's the same numbers, so you can see with the calculation of the kinetic energy, there was a loss in kinetic energy of 0.25. So going back to my main result, you can now see how the kinetic energy changed and how the energy overall changed. And like I said, there was a loss of heat or vibration or deformation or whatever, the kinetic energy was lost and the momentum was conserved throughout the whole thing. And I hope you enjoyed my video and can further understand the concepts behind a maximally inelastic collision. Thank you.